Hello guys, welcome to this first part of the SQL course for beginners. Nowadays, SQL is one of the most in-demand skills in order to become a data analyst or data scientist. Thus, learning and understanding SQL will help you a lot to get a job as data scientist or data analyst and to work in a better way in data science and data analysis projects. So in this course, we are going to see first what is SQL, what is an RDBMS, what is database and what is a relational database. We're going to mention some famous RDBMS used in the real world. We'll explain tables, ER diagram, keys, constraints, SQL indexes, MySQL data types, SQL command types, and finally, we're going to have some hands-on all the defined concepts above using MySQL. To download SQL, you can click on the link above or you can find the link in the description. So first, what is SQL? SQL stands for Structured Query Language. It is designed for managing data held in a relational database management system, the RDBMS. So RDBMS stands for Relational Database Management System, and it is a type of software that allows you to manage data in a relational database, mostly using SQL. So database is a collection of data stored in a computer system, whereas a relational database is a type of database where data is structured and stored in tables, where generally tables are related to each other by keys in order to form an ER diagram. So famous relational database management systems used in the real world, we can mention MySQL, the one that we will use in this tutorial. We have Microsoft SQL Server, we have PostgreSQL, Oracle Database, etc. So what are tables? Tables are database objects where data is structured and organized in a row and column format. As you can see here, the horizontal line in blue represents a row, or it is also called a record. And columns are called fields or the vertical lines. So we have ID, first name, last name, and phone number. These are called columns or also fields. We have two types of keys. We have the primary key, which is a special column in a table used to define each record in a table. It is unique for each table, so each table will have only one primary key. And we have the foreign key. It is a field or many fields, so a table can have one foreign key or many foreign keys in a table that are used to link tables. So a foreign key in one table represents a primary key in another table. ER diagram stands for Entity Relationship Diagram, and it is a graphical representation to show the relationships between tables. Here we have an example of an ER diagram. As you can see, we have three different tables. We have grades, students, and courses. Each table has only one primary key. For the grades, we have grade ID. For the students, we have student ID. And for the courses, we have course ID. But also, the grades table has two foreign keys. We have student ID and course ID, which are primary keys in the two other tables. For the foreign key in grades, which is student ID, it is a primary key in students table. For the course ID, it is a foreign key in the grades table, and it is also a primary key in the courses table. So as we have mentioned, a foreign key in one table is a primary key in another table. Constraints. Constraints are rules that are applied on columns. Primary key and foreign key are types of constraints. When we say that this column represents a primary key, it is type of a constraint. We have not null constraints, which means that the column cannot have a null value. Unique, all values are different, which means that no duplicates. Check, so it is used to check a given condition. And we have default, which is used to set a default value if no value is assigned. For example, if the value is null, with the default constraint, you can give it a default value. Then we have the indexes. Indexes are used to speed up data querying. The query is applied only on the selected columns to retrieve data. For example, if we have a big database and we have big table, which has a lot of fields, a lot of columns, so you can create an index and select some columns that are mostly used by the data analyst. So by using indexes, you will only retrieve data from the selected columns, and you will gain time because you are not going to analyze all the data set or all the table. We have three commands when working with indexes. We have create index, which is used to create an index, create unit index, which means that creating indexes with no duplicates, and we have drop index, which is used to remove an index. MySQL data types. So with SQL, we work mainly with three data types. We have numeric, string, data, and time. And for more details, we are going to the official documentation of MySQL in order to understand better the data types. The link is available in the description if you want to follow with this video. Okay, so now as we can see here, when you click on the link provided in the description, we have chapter 11 data types. In the table of contents, we have numeric data types, data and time data types, string data types, and some other data types. But most of the time, in practice, the three first types are the most used. So we have numeric, date, and string. So if we click on numeric data types, we can see that MySQL supports all standard SQL numeric data types. They include the exact numeric data types, so the integers, as well as the approximate numeric data types, which are float, real, and double precision. So if you want to understand in depth all the different data types, you can click on one of them, for example on double precision, and it will give details about each data type. So the second data type is the date and time data types. So as you can see here, the date and time data types for representing temporal values are date, time, date time, timestamp, and year. For example, if we click on date, so the date type is used for values with a date part but no time part. Okay, so only for dates, and it is in the format of year, month, and day. And here we have the range. So the same thing, if you want to understand in depth all the different data types, you can only click on one of them and you will have all the information. The third one is the string data types, and here we have 8 types. We have the character, so the varchar, binary, var binary, blob, text, enum, and set. For example, if we click on the char, so the char and the varchar types are similar but differ in the way they are stored and retrieved. For example, the char can hold up to 30 characters, and for example, for values in varchar columns are variable length strings, and the length can be specified as a value from 0 to 65,535. Same thing for the other data types. If you want to understand in depth, all the information are available in this chapter. Now we'll talk about the SQL command types. As you can see here, we have 5 different types. We have DQL, DML, DDL, DCL, and TCL. The DQL stands for Data Query Language and used to select data from database. It has only one command, which is the select command. The DML stands for Data Manipulation Language and used to modify and update the database. It has 3 commands. We have the delete, the insert, and the update. The DDL stands for Data Definition Language and used to create, define, and modify the database schema. The commands we have the alter, create, drop, and truncate. The DCL stands for Data Control Language and used to control access to data stored in database. For the commands we have the grant and the revoke. Finally, we have the TCL, which stands for Transaction Control Language and used to group a set of statements into a single logical execution unit. We have 3 different commands: the commit, rollback, and save point. Okay, so when we open MySQL Workbench, we get the following window. If you haven't already installed MySQL Workbench on your computer, you can find the link in the description to download it and to create new connection. So we click on local connection, and we get the following window. So as we can see here, we have the navigator where we find the schemas, which are the databases. We have the window where we create our queries, and you can create new ones. So create new SQL tab for executing queries. Here we have SQL additions. Here we have the output, so the action output with the time, the action, and the message. Well, of course, we have the duration. And here above, we can choose whether we want to display the schemas or not, display the action output or not, or the SQL additions. So we are going to work with the schemas and the query tab. As you can see here, we have the system database, which is always present, which is default database. We have 2 more databases provided by MySQL Workbench, and the DB test, which is a database that I have created. Okay, so to create a database, we have 2 methods. We can cap in here and create new schema in the connected server. So we give it the name DB1, and we leave everything as it is. We click on apply. Okay, apply, finish, and we see the database. It is displayed in here. To see the tables, so we have tables, views, stored procedures, and functions. The same thing for the provided. So we have the word, we have tables. In each table we have the columns, the indexes, foreign keys, and the triggers. So we are going to create a new database from scratch with tables and columns. Okay, so come back into query, and here we have the execute command. So execute the statement under the keyboard cursor. Here we have the limit number of rows. So you have limit 10,000, and you can display up to 50k rows. Okay, and for example, if you want to create a database, we write create database. We call it db2, for example. Okay, we execute the query and we refresh the schemas, so we see our db2 is created in here. For example, if we want to use one of the provided databases, we can write use, for example, Sakila, and we execute the statement. We get the table, so we are inside this database. For example, we can select all the rows in the actor table. For example, to do that, we write select all. Okay, so the asterisk means all from actor. Okay, execute, and here we do have the output. Okay, so actor ID, first name, last name, and we have the last update. Okay, now as you can see here, I have written all SQL keywords in the uppercase and the titles, the remaining data, in the lowercase, and all the queries need to end with a semicolon. Okay, so the syntax is like this. It is better to write your queries like this. To add a comment, we use double dash, so dash dash. This is a comment. Okay, and if you execute that, nothing will be applied. Okay, so this is a comment. And for example, if we want to use strings, okay, so we execute that, and for example, we add a condition where, okay, first name, for example, first name equals to, you can use either double quotes or single quotes. Okay, for example, if we use single quotes, we will get the following. Okay, and if we use the double, it is the same thing. Okay, but it is recommended to use the single quotes. Okay, so if we use single quotes, it will be better. Okay, so we execute that, and each, for example, each word, it will be in separate line. For example, you write select in one line, then you write from your table, then you write your condition. Okay, it is better than putting everything in the single line. Okay, it is possible, but it will be clearer if we put each word in a separate line. Okay, because as you can see here, even though if we write all the words in separate lines, the query will be executed at the end of the semicolon. It will not execute only select all. Okay, so the query is all this. Okay, so this is an example of a query where we select all the rows from the actor table where the first name equals to ed. Okay, so this is a query. Now, if we want to create another database, for example, that we will call create database. Okay, we call it, for example, students info, right? We execute that, and if we refresh, we get our students info database. We are going to use that, so we write use students info, right? We execute, so we are inside our database. Now we will create tables. For example, we create the first table, we call it create table, call it students. Okay, so in order to create table, you need to put at least one column. Okay, so we start by the ID, so student ID, it will be an integer and it will be not null. So we have the column name, we have the data type, and we have the constraint. Okay, the second, it will be each student has first name, same thing, it will be varchar with 20 characters or 30 characters as you like. We can also add constraint, it will be not null. Okay, same thing, we write last name, it will be varchar 30, and for example we add date of birth. Okay, date of birth, it will be a date. Okay, so we can define our table like that, and as we have said, each table needs to have a primary key. So to create our primary key, we write primary key. Okay, and we select student ID. Okay, so if we create our table, we execute the statement, and if we refresh, we get our first table, which is students, and it has all the columns. So student ID, first name, last name, and date of birth. It doesn't have any foreign keys. Okay, and we have any indexes. We haven't created any indexes. So we create another table. We call it courses. Okay, and in this courses we will have course ID, which will be an integer, and also it is not null, and we have also the course name, which is varchar, for example. Okay, which can be up to 30 characters. Okay, and we create our, we also add the primary key. So it will be the course ID. Okay, and we create our table. So we have another table. If we refresh that, we have two tables. So we have the courses and we have students. And now we create a third table. So we call it create table. Okay, I call it grades. Grades, and it will have also grade ID. Okay, so the grade ID, it will be int and not null. Okay, we'll also have the student ID. Okay, and it will be int also. We'll have the course ID, it will be an integer. Okay, and we have the grade, which can be a float. All right, so here we created our table. As you can see here, I didn't define the primary key inside the table as I did. Okay, what I will do is that I will add the primary key using another method, which is alter table. We have grades, and we select add primary key, which is grade ID. We select the statement. Okay, so here we have added grade ID as the primary key in the grades table. Okay, now if we want to drop a table, for example, drop table, right, drop table grades. Okay, so before I execute that, when I refresh, we have the grades table, and when I drop the table, execute, we don't have the table anymore. Okay, so as we have said, each table has a primary key, so we have two methods to add the primary key, whether when you create the table or you can add it. And also, as we have said, each table can have one or more foreign keys. So in the grades table, we can add two foreign keys. So we will have student ID and the course ID. So each grade, it will be for a student for a given course. Okay, so the course has a title as it has an ID, and each student has first name, last name, has an ID and date of birth. Okay, so we can add the foreign key using this method. Okay, so we write foreign key. Okay, foreign key, which is student ID. Okay, all right, references, it is in the students table and it is the student ID. Okay, so we select student ID as a foreign key in the students table. So if we execute that one more time and we refresh our table, we get the grades table is in the students info database. We can also add the course ID or foreign key using another method, which is alter table. Okay, we have the table grades, so add foreign key, which is course ID. Okay, and it will be so references from the courses table, and the column is the course ID. Okay, so here we have our statement alter right. So we will see the primary key, the foreign key, and the link, the relationships between the three tables when we create our ER diagram. Okay, so to create an ER diagram, we go to database, reverse engineer, okay, local connection, stored connection, local connection, we click on next, next. So we select the student info, right? Next, next, execute. So here it has created an ER diagram for us, as you can see here. So we have the grades table, students table, and the courses. As you can see here, the grade ID is the primary key for the grades. The students ID is the primary key for the students, and the course ID is the primary key for the courses. Okay, for the student ID and the course ID in the grades table, it is represented as foreign keys. They are foreign keys in the grades table. As you can see, when we click on it, we have the relationship between the three tables. So this is how we create an ER diagram. So we have arrived at the end of this first part of SQL course for beginners. I hope that you have learned new things. Thanks for watching and see you in the second part.